Hi everyone, welcome back to the Cyber Core Skills course, module number 1, Practical Implementation of Networks. So what we're going to cover within this lesson, we're going to do a quick introduction and overview of networking, some of the basics, just a very quick overview. We'll cover within that OSI model, overlook encapsulation, we'll have a look at IP address and MAC addresses. We'll go into some of the major stuff, which is subnetting and then VLSM. We'll then stop the overview, then go into more practical and the main objective of the video for configuring and implementing IP addressing. We'll do that not just on network devices, but we'll do that on different types of hosts as well to make sure that we're familiar with different types of operating systems. We'll do an introduction to Cisco iOS. We'll then talk about switching technologies and go into deeper within that. So we'll talk about VLAN, spanning tree protocol, Ethernet channels and trunks. Then we'll go into layer 3 technologies. So that's router on a stick or into VLAN routing. We'll also talk about first hop redundancy protocols. A little bit more, so now we're going to step into the world of routing, static, default, OSPF and EIGRP, all very similar in theory, but just a few different configurations. Looking forward to that. We'll then talk about layer 2 WAN connections with PPP and CHAP and how that even is used in your own home. We'll talk about NAT. Then we'll go further into network security with regards to port security, VLAN policing and span ports, and expand on a few more technologies. And because we're doing this practically as well, with regards to the setting up of all these different technologies, we're going to need to know how to troubleshoot a lot of these. So as well as the show commands or verification commands we know all along, we'll do a quick summary of all the troubleshooting commands we know, and we'll go through them and make sure we list them and know how to use them practically. So just talking about some of the equivalent quals that this course brushes on is the Ccna, Cisco Certified Network Associate. The current exam is the 200-301. It is a beast, but what we're talking about and what we'll practice touches on some of that. More vendor neutral qualification, the CompTIA Network Plus, just gone through renewal last year, which is vendor neutral but a lot of theory, and you also have to know about other vendors as well. So we sort of brush on a lot of the theory on these exams, so it might be worth looking into some of these after the module. The tools that we're going to be using are Cisco Packet Tracer during this for configuring, just because I've not got any availabilities of real physical kit at the moment. Some additional options that you might want to look into are GNS3. We're not going to be using it on this course because what GNS3 allows you to do is pull in the network environment as well as the domain, but and use them against virtual machines and exchange packets and really analyze. And it is a very good platform. It's just quite complex to set up, but we don't require it for this level of knowledge at the time. Additional, what we can look into is Wireshark. It's really good for troubleshooting if you have issues, and what you can what you can pick up based on the traffic that's going between ports and analyze that a bit further, so you can pick up packet types, data, and this is sort of relates a little bit more to what we're going to be looking at the OSI model. So covering off, we're going to do a quick basic overview of networking, into IP addressing, then into more practical. So in front of us we can see a very basic network diagram of 3 networks. Some of you might be looking at where's the third. Actually the third sits here within the WAN connection. So this diagram we're going to be using and building on it effectively for our configuration. We can see we've got our LAN area with 3 clients, and then we've got our corporate area, our company, consisting of 1 domain controller and a web server. We're going to be implementing this both through the network implementation and then building this out quite properly within our Windows domain. So this is sort of going to be quite a common diagram we see a lot. So if we're talking about Cisco Network Packet Tracer, one of the practical softwares we're going to be configuring our devices using, this is our view. So I've already mapped it out. I'll be supplying the files for this and the links where to sign up and download the software, so you can have a go yourself within the notes of this video and within separate links. And each of these devices is interactive. So what I've already done is pre-configured this end, and we're going to be implementing configuration on the switch and router, Cisco IOSs further, and then practically setting up IP addresses and troubleshooting them. Cool. So going back to a quick overview of theory and putting it into a way that I sort of feel easier talking about it. And when we mentioned layer 2 and 3 already, I just want to make sure we're all talking off the same sheet. So OSI 7-layer model, various ways of remembering it. I like to say, please do not throw sausage pizza away. Layer 1 to 7, a lot of people get confused with the order, but it's reverse. Physical layer, data link layer is layer 2. So within that we talk about switches and MAC addresses. Within layer 3, networking, we talk more about routers and IP addressing. So it does mention there, and then Ethernet with the MAC addresses for layer 2. There's lots of technologies that fit in between here, so that we're going to be talking about. So data link layer, we've got things like spanning tree protocol. Within networking layer, things that we don't have there, but we'll talk about routing protocols. And then when we hit layer 4 is where, between layer 3 and layer 4 is where sort of networking devices stop. So this is done by your client, your host machine and your computers, whereas layers 1 to 4 is where your networking sits and your networking layers sit quite easily. We'll just quickly talk about encapsulation of data just up to layer 4 at the moment, because I don't want to press on too high. We start with, if we talk about data moving between 2 points and the way data gets added at every layer, you can see at layer 7 you've got your data, and then layer 7 header gets added, layer 6 gets added at presentation layer. Moving on from this, at the network layer, what we have, it's not just a layer 3 header. This diagram's quite vague, and what I quite like about it is what happens at layer 3 is there's a source destination IP gets added. At the data link layer, we have, as in addition to all the data that's being processed and added by the computer, we have the source and destination MAC address, as well as this little bit at the end, a cyclical check sum, which is basically a pseudo calculated value based on the length of that frame that sits at layer 2, and it's used within some error correction, not within a lot, not as much with layer 4 does with TCP, and doesn't guarantee delivery, but it's used to affirm whether it's whole data or not. So I just wanted to talk about a little bit of encapsulation and de-encapsulation within the networking layers, which is layers 4 downwards really within networking, and what gets added at those encapsulation. We'll talk about OSI again when we talk about application, presentation and session layers, when we talk about domains more and into Linux and look at those real commands. But for now, if we talk about layer 4, we know what gets added at each layer. So at layer, what I missed out was layer 4, so we talk about TCP and UDP port numbers. So we'll be talking about them when we hit like NAT. Source and destination ports, source and destination IP addressing at layer 3, source and destination MAC, as well as the CRC at the end, and layer 1, that's when it gets translated. So, taking a bit of a dive into IP addressing and Subnet masks, we'll talk about it a bit more at length. But what you might recognise from a standard IP address, .1.0, 255.255.255.0. So we have an IP address with the Subnet mask, and that identifies the network position. That's a logically assigned address within a network. We'll be talking about that a little bit more later. CIDR, and with that you might see something like a /24 or a /30, quite commonly seen. We'll talk about how they're going to be worked out and used more effectively. We're going to be talking about IPv4 and 6 and the technologies around that. So with regards to IPv6, you might see a sort of an IP address that looks like this, for example. Okay, and we're going to be talking about not only how they look, how they're used a little bit, but more commonly how they're abbreviated as well, which is quite commonly used even for programming them within networks. We'll talk about public and private IP address spacing and how that's used even within your own home. We'll talk about loopback addresses, which loopback addresses start with 127.0.0.1 and how we can use them and what we use for testing. We'll talk about APIPers, which start with 169 and then and how they're implemented and what the purpose of them are for and how we can spot them. And linked local addresses, especially within IPv6 and how they're used. So you might see them as FE80. Okay, cool. So moving on. So an IP address is a 32-bit value address which is logically assigned to a computer. It being logically assigned means that it can be it can have many of them, and also they can change depending on what network your computer's on, or even if the computer's moved, where a MAC address is a statically and physically assigned address. So it's 32 bits, and without going too much into the binary, which we will be going on later a little bit more to understand the theory of subnetting, a IP address is broken up into 4 octets, and the reason why it's called an octet is it's got 8 ones effectively, with 8 bits within in each octet. So the lowest IP address we can have within IPv4, and by default whenever I mention an IP address, probably during this course at the moment, I do mean IPv4, because generally within Western world we're reliant heavily on IPv4 addresses even to this day. I think we have technologies out there that and revival of IPv6 to move to, but still within training, within industry and within practical builds, we're still quite heavily within IPv4. Because of some technologies, but also within the fear of building onto it. I've got quite a good module built up for IPv6 that I will talk about, and just to understand how that is actually not a very complicated subject. So back to it, the lowest value we can have is 0.0.0, and the biggest number, the biggest address we can possibly have .255.255.255.255. So when we talk about an 8-bit binary, we can have 0 to 255, total number 256 different combinations effectively, because that's including the 0 itself. And what each IP address is assigned with is a subnet mask. So I've only written 3 octets value there, and you might often see 255.255.255.0. That's a class C IP address. We're going to be covering this off and again in a minute. And what a subnet mask does is identifies the network portion and the host portion of an IP address. So if it's a 255, we've identified this as a network portion. So 255.255.255 says that this portion of our IP address is network, and it will not change, it's rigid, whereas the last host, the last section, the last octet of this IP address being 0 declares it as host. So we can use anything within this last octet. It's getting a little bit messy now, but the case is we can use anything from 0 to 255-ish. We can use anything within that range. Governance say, and the RFC states that we currently use one IP address is usable for the network address, and one of them is used for a broadcast address. So when we're trying to talk to all IP addresses, all computers within this network, we'll use the broadcast address, and the network address is used to identify that network, so it's the very first number. So generally, if I just quickly write this out and start again, and use it within an actual usable range, because not many people would use 0.0.0.0 as a network, but not saying it's not the first IP address of IPv4. But so if I use what we tend to use at home, and we're going to speak more about this IP address range in a minute. Okay, so with accompanying subnet mask, we can identify their host and network values. So really all we're going to be using is this portion. So how I like to write it out, and we'll see this pop up a lot, the network, the first IP address we can use, the last IP address we can use, and the broadcast address we can use. So within this, 192.168.0.0, 0 is the network and 255 is the broadcast. So it's the first one and the last one. And then everything in between is usable, or the usable host range. So within this one, we've got 192.168.0.0 is the network address. If we go to maximum, 192.168.0.255, the biggest number is the broadcast. And then we've got .1 and .254 is the last one. So that's the usable host range that sits between here. So if I have a random IP address of 192.168.0.14, within that range, the question is that usable? And the answer is yes, it is, because it sits quite happily between this range, and actually it's probably within the scale, it's probably about there within the range of IP addresses we can have. If I have an IP address of 192.168.14.14, I'll give you another question. Can we use that IP address within that range? And the answer is no, because we've identified the host portions and network portions within this range to say that we can only use, and also we can only talk to, within our own LAN, within our own network, those IP addresses. So because this 14 sits in the third octet, and it's different, it sits outside that network range. It sits actually within an entire different network because the third octet's different. Cool. As long as we get that, and then those IP addresses are associated with the network cards on a physical computer, and then the devices we use, if we wanted to talk between these two, would have to be a router. So we'd have to be able to set up a router, set up the routing, and make sure that they effectively communicate between them. So when we talk about the LAN and the corporate build diagram we saw earlier, that's what we need. We need those router infrastructure, and that's what we're going to be configuring. Cool. So IPv4 versus IPv6. We have IPv4 addresses and IPv6 sat within this. This is one of my virtual network cards I have on a client. So here we've got IPv4 addresses set up. So 1.13 sits within that range. I've got a subnet mask associated with that, and actually that 255.255.255.0 is a default subnet mask, and it's a very common one that we see with regards to 192. We'll be talking about that in a minute. We have default gateway, which is the IP address of the last point of exit and entry within that network. So that's assigned with .1, and this is very common within your home environment. And also we've got our IPv6 addresses, and delving into that more, you can see our link local address, FE80. We have, whenever we talk about IPv6 addressing, it sits within a larger range. There's far more IPv6 addresses than grains of sand on earth, and everybody can have over 10,000 devices in IP addressing, which is good and necessary, especially nowadays. Even cats have SIM cards nowadays, but for GPS feeds, I believe. But there's a lot more IP addresses than IPv4. So we can see both there that this interface, this wireless interface, has got both IPv4 and IPv6 addresses. So it can be used to talk on both levels, and this strategy of using both is called dual stacking, and it allows for quite good network infrastructure, because you can even have a hybrid system of using both, or you can stick with just one. So half your infrastructure might be IPv6 and half might be 4, and this allows the computer to speak to both. Cool. I want to dig a little bit deeper into IPv6, just so there's a certain layer of confidence that gets reached with regards to this topic. So what I've done realistically is done an NS lookup on Facebook, and we can see here it's got both an IPv6 address and an IPv4, and what we notice is we got Facebook within the actual IPv6 address space reservation, and they've been quite creative with regards to this IP address scheme. So they've obviously, once the address space has been released by IANA, the International Address Scheming Resolution people, they jumped on this and managed to get this address and purchase it, so they could use it as a reservation and a reference point. Really intelligent they've done, and it's quite amusing to see. So breaking this down sort of further on my notes, IPv6 is an 128-bit alphanumeric address space, and with it being 128 bits, it acts exactly the same as IPv4. And what we can do is do what we've just done with regards to IPv4 and work out the network, the broadcast, and actually the usable host range. So we assume that IPv6 is enough addresses, but we still have the basic fundamentals. We've still got a network address, a broadcast address, and we've still got usable hosts. So if we were to say this is 128 bits, and we said within IPv4 it's 32 bits, and later what we're going to talk about is a Class C address is 24 bits. So roughly it's the address, the network portion was 2/3 of that address. So what I'm going to do is just draw a line here. Okay, so what I've done is just said that the first half of this IPv6 address is network, and then the second third is host. And working with alphanumeric, we've got 0 to 9 and then A to F. So if we talk about the lowest value is 0, and then the highest value is now F. Okay, that's what gives it so many more combinations. So with regards to this broadcast, this IP address, and if we are going to segment it and say just relate it to IPv4, just and sort of just use the fundamentals of what we already know, what we can say is Facebook actually, that half might be its, that phase section might be part of its network, and the book might be part of its network, its host allocation. So what we can do is say 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. So that's its broadcast. It's correction, that's its network, because that's the first available. If I go broadcast, so we say from this section forward, so we say the 2A03 all the way up to the FACE section is all broadcast, is all the network address, is all the network portion of that address. Whereas if the remaining section is the host section, so we go for maximum, we go for everything turned on, and we go for the maximum value, which is all F's. F, 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 colon, F, 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 colon, F, 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 F. Cool. So that's the broadcast. We plus and minus one, so we just add one on. So we say 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1. So that's the first available host if Facebook did use implement this IP address scheme, which is probably quite usable. Normally you would say /64, so normally they would cut it directly in half, but we've gone for this portion here. So the last usable host within this network scheme is FFFFFFFFFF, and then going back A, B, C, D, E, F, E.
So the last one is F's all the way along, colon, F's all the way along, colon, F, F, F. Oh, I might look right now. E. Cool. So it's using what we know about IPv4, but implementing IPv6. Hopefully that does clear a little bit up. There is one more thing I just want to talk about with regards to this IPv6, because often, and we've seen it here, we've seen that we're missing a few numbers, and this is what we call shortening or abbreviating IPv6 addresses, and it saves people remembering so many numbers. We see a little bit of abbreviation here, we see a little bit of abbreviation here. So what we can do is, if for example we're using a very simple, fundamentally there's two rules with shortening or abbreviating IPv6 addresses. We can take away the leading zeros, and we can take away, if there's groups of zeros together, we can reduce it down to a single zero space, but providing there's no letters or numbers in other letters or numbers in between, and we can only do that once in an address. I'll give you an example. So if I have 2001 colon 1000 colon 0001 colon and anything else after, what we can do here is we can shorten this down to an abbreviated IPv6 address. So 2001, because it's these two are not leading, we can't shorten that at all. But what we can do is reduce this space down, but we have to keep this semicolon. So what this reduces down to is 2001 colon colon 1 colon colon 1, and then colon colon, and we have the rest. So
moving on and looking at CIDR, and I've not just started drinking, by the way. CIDR stands for Classless Interdomain Routing. It's a way of summarising a subnet mask and also then identifying which portion of an IP address, whether it's IPv4 or IPv6, is host and network. So as we said, when we work with IPv4 addresses, for example, if I have an address of 192.168.0.25, for example, its default subnet mask, which I'll speak about in 2 seconds, is 255.255.255.0. And when we spoke about a IPv4 address, we said there's 32 bits in total. So this 32-bit number's key, okay? If I was to break 32 bits up into these 4 octets, 32 divided by 4 is 8. And also, within an IP address, we talk about denary as being the calculation, because it's going up in ones or zeros. So for a 255, within, not going yet again too far into binary, we have 8 ones. 1, 2, 3, 4, 5, 6, 7, 8. And when it's 255, all ones are turned on, so we have another 8. And then 1, 2, 3, 4, 5, 6, 7, 8. And then where we have a 0, there's 8 zeros because none of the bits are turned on. Okay, so that is the binary value of that subnet mask. And what we do simply with CIDR is just count the ones. So we have 8, 16, 24. And we say the CIDR for this subnet mask is /24. The useful bit about CIDR is that you can include it with an IP address, and very quickly, and within a short space of time, you can identify that it's a Class C IP address, or you can identify and even program routers and switches using this method. So it saves you typing out the full subnet mask. You can say it's a /24, boom, it assumes what subnet mask you mean. And that's how sort of a lot of devices work. So just going back to class A, B and C and subnet masks, they have default subnet mask, default ranges and default usable IP addresses. So a class A subnet mask is 255.0.0.0. Class B is 255.255.0.0. 255.255.255.0 for a class C. So it's evident if a 255 is a network and a 0 is a host, then the host portion with a class C is smaller than a class B, and then it increases significantly with a class A, giving 16 million possible addresses, and then I think with a class B it's something like 32,362 or 66. But anyway, back to it. So for this, we count the number of ones that are turned on. So if we have 8, 16, 24. So a class C address has 24 bits turned on, or written with a slash notation, and that's also what it's called. It'll slip between the two, CIDR or slash notation. So class B, 16, class A, 8. If I'm to prove the IPv6 bit to you, so just going back to when we covered it, this Facebook address, if we said that an IPv6 address has 128 bits in total, and it's in blocks of 4 characters, and there's 1, 2, 3, 4, 5, 6, 7, 8 blocks, then we say 64 blocks is going to be 64 bits. So if we have 1, 2, 3, 4 blocks, and draw a line here, and we want to allocate this as our network portion, and we say, okay, this portion is going to be our host. So what we can do is literally we've cut our IPv6 address in half, and we said that's a /64 at the minute, and we can address it left, we can address it right. You don't often get with IPv6 addresses anything smaller than a 64. Normally it sort of chops into that, and it'll be next a 72, for example. So that's how we can use an IPv6 address with regards to CIDR. So you don't often, well, I've never seen a subnet mask on an IPv6 address, but often you've seen it on a IPv4 address. But that's where we're at. We can use other numbers, and that's what we're going to be learning a little bit later. But we'll hit home first of all with CIDR. So 252, 254, and 255. Cool. So that's going to be our subnet mask. And what this is going to be is our block size, okay? So I'm going to give some numbers, and we're going to do some working out, and our block size is basically saying how many addresses we have, how many IP addresses within a certain range that we have. I said our bullet point is here. So up to this point we have really small 192.168.0, and this is where our bullet point is, just here. This is what we're playing with now, this section. So we're gonna have a little practice round, and then we're gonna see what's gonna fit that previous build that we just did. Okay. So what I'm gonna do is step in. So I'm gonna say we've got ones all the way along on our subnet mask, and we're here. When normally this is a 0, we're just gonna step in, and we're just gonna draw a line there and add that here. Okay. So this 1 in this position as a binary value is 1 to 8. Okay. Whereas this is a network bit, network the rest of the hosts. So what we're doing is increasing the number of networks, but decreasing the number of hosts. And what we're saying is our block size is the number of hosts available. So we've got our subnet mask is going to be 1 to 8, and our block size is also going to be 1 to 8. So within this, we've got 192.168.0.0 is our starting point. That's our first network. And what we've effectively done is saying 1 to 8, we say how many times does that go into 256, and that's twice. So actually we've got 2 networks. We've got 2 block sizes of 1 to 8, 2 equal networks at the moment. So we've got 192.168.0.0. Then we've also got our next network, which is 192.168.0.128. Okay, and this is where the broadcast comes in again. So this is a sort of quite fast and dirty way of doing it. There are, as I said, there are different ways, but what we do is simply we go to our max value and then we add 1 and take 1. So what's our biggest number we can work with? I've said it a few times before, 255. Get that written in. Then we have, there we go. Then we have add 1 and take 1. So if we add 1 first and last, so if we add 1 to 0, go on, it's 1. Even I can work that one out. And if we add 1 to 128, it's 129. Cool. And if we take 1, so when we take 1 for the broadcast, it's take away from 127 at 128. So the broadcast for the first network is going to be 127. Then if we take 1 away from that again, so 254, which we've seen before as the last usable, and then it's going to be 126. So this as a subnet mask, which is here, is 1 to 8. So the subnet mask for this is 255.255.255.128. And from what I said is, let's work out the CIDR. So how many 1s are turned on? We've got 8, 6, I'll do it a different colour. We have 8, 16, 24, but we've just stepped in 1, so it's now 25. Because there's literally just 1 turned on here, which is 1 here. Okay, so subnetting is basically using the subnet to fit what we want. So we've actually now got 2 networks. We've got the 0 network and the 1 to 8 network. We wanted, for the previous build, we wanted 3. So we can't have that. If you're now looking at this table going, I think this will fit, you're pretty much right. But actually, the question is, our block size is how many IP addresses we have. So how many times does 64 go into 256? And that's 4. That it's sort of this table. It's using this table, but almost reversed for the number of networks you get. Cool. So I'm just going to copy this out. I'm just going to move this, because this table is what I rewrite for everything. Copy that. And then what we're going to do is just rub out the whole thing. Just start again. Right, let's start afresh. So let's make it nice and neat. What I'm just about to do is go the opposite side. Put this at the top. Always write that out every time we do subnetting. There's also a really good website called subnettingquestions.com, and that then you can practice all day long. I practiced just before doing this lesson. It's always good when I used to teach it was 5 or 6 questions before you teach it. It sets you in for getting it just round your head. So my favourite subnet mask is this one, or my favourite subnetting bit, 4. And when we look at block size of 4, and when we say that it's got to have a network address and a broadcast and have usable IPs to be useful, so that gives us 4 IPs, with the first one being a network, the last one being broadcast, so it gives us 2 usable. And this is what we use in a point-to-point network. So if I'm having a router, a router, might as well go for 4. The reason why I do the jaggy line is it's a serial connection and can also simulate multiple networks between this. It's often done within cloud diagrams. So, but for this sake, I've got 4 routers, I've got 4 networks in total, and I really want to be really effective with my IP address scheming. Okay, with schema, with my plan, and I want to start with this, with our classic network of doing purple. I'm starting at 192.168.0.0 again. Standard subnet mask is 255.255.255.0. Can you tell me what with this subnet, what my subnet mask is going to be? That's right, 252. So that 0 is the first network, and we said our block size is 4. So if I totally just allocate the IP addressing here, so I'm just going to leave this blank. So if we go up, if we just go network and last, because we can all count. So our first network is 0. Then we're going up at steps of 4. Normally I've got a bit of they call it a subnetting dance, but I'm not going to get up and dance. But if you like and subscribe or something, maybe I will. But so we're going up in 4s. So 0 add 4, 4. 4 add 4. Even I can work this one out. 8, 12, 16. Normally it's tricky, that one. So those are our network addresses. Our first, I'll do that in a slightly different colour, just because I'm squeezing it in. Oh, let's go for nice pink. Let's go for green. So 1, 5, 9, 13, 17. So that's our first, and we'll go for last. Sorry, we got last there. I'll just move that along a bit so we fit broadcasting, just so we're including every number. So last is, we add another one. So 2, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18. And you can hear me almost not including a number because the broadcast is literally just counting. Now, red. We'll go for broadcast is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and you can see it continues 13, 12, 13, 14, 15. So we've got our broadcast. Now what we can do is plan these networks out and looking at these point-to-point connections. So I'm just going to go for a nice bright yellow. Oh, that's good. So each interface has an IP address and a router when it's in use. If not, it'll be shut. We'll see that later on in the course or lesson. So 1, 2. So this is network 1. So we've used this one. Okay. Some people get confused and try and put it here, but it's a network is 2 points that can communicate, whether that's through a switch or not. And these are directly connected, but still they need to be able to communicate. So they need to be on the same network, because if they're both speaking to each other, they can also use the broadcast address as well. So they might be shouting at each other on 3, but they might talk individually between themselves on 1 and 2. But still, routers don't pass broadcasts, so they'll only be discussing it between themselves. So the next set of usable is 5 and 6, then 9 and 10, and then 13 and 14. And what we've got is loads of networks left over, so if we want to expand this at any point we can. This is class C subnetting, okay? We can mix the two together, but that gets onto VLSM, variable length subnet masks. And I'm going to build up to class B, and then we'll talk about them, variable length subnet masks, after that. Okay, so moving on from this build. Hold on, I did promise a 3 network Class C build, didn't I, using this 192. So I'll just go back to make sure I cover out what I've promised. So I'm not gonna. Oh, there we go, quickly. So we had 192.168.0.0 as our starting point, and it could be anything. We could be because of that the strange range we had within the 192.168. We could have a 10. Yeah, I'll leave it there. I'll do that. At the end of the day, this is the network portion. That's the host portion. It doesn't matter what the network portion is, as long as we're correctly allocating the host section. So we had computer, router, computer, or laptop. Cool. 3 networks, and we said 3 equal networks, which we know we can't do because it goes up in reverse order. So actually, network-wise, we've got 1, 2 networks, 4 networks, 8, 16, because it's reversed. So we're going to be using this step count. So we're going up in 64s. Our Subnet Mask is 192 using our little cheeky table. It's not that cheeky. So, but we said 3 networks, okay? So this is our starting point. 0, add 64, because this is what we're going up in. This is our steps, our block size. So 0, 64. 64, add 64 is 128. And then you can 192. Cool. That's actually correct. I've amazed myself. There's very common numbers, and once you get into it, you begin to see the pattern. So that's our network address. What's our broadcast? It's ours. So we just take one away from the previous number. So it's 64, 63, 128 is 1227, 192, and this is why I've written down this one, because you need this number to work out the previous number and also the broadcast address. So that's 191. Then if I go for pink, let's go for it. So 165, 129. Don't need to do it for the next one because I've only got 3 networks here. And then if I go for a nice subtle red, maybe, just for the, so that's our first, last. And this is why I regimentally write it out every time, because you get more familiar with it. So 62, 126, and 190. But let's allocate this through. So I quite like using, and you'll discover this, quite like using the lower half for the hosts and always the higher half for the default gateways. So in this diagram, I'll show you what I mean by that. So for yellow, so I'm going to go for, next though, what's our subnet mask? So our subnet mask for this entire build is going to be 255.255.255.192. Our CIDR, because our full stop is here, or here, sorry, and then we've gone for 255, 255, 255, and this would normally be 0. We've stepped in 2 bits, and this is our bit of interest, or our active bit. So that is 24 up to this decimal point, up to here. So 24, 25, 26. So it's a slash, also known as a slash 26. See, this is where I said before we would step into it. And so let's allocate it effectively. So we've got .1 for our first usable. And also want to add in the last usable for the default gateway. So this default gateway is a point on a router. So I'll say .62 there. I'll allocate this, and it's naughty, and I don't feel right doing it, but allocating an entire 64 block space for a point-to-point connection, which, as we saw earlier, we could be using this. We could be using this network for quite easily, and it would be far more effective. But anyway, I said 3 equal networks, so I'll go for 65, and I could go for I could go for 126, but I'll go for 66 just because it's incrementing up then. And so we've got this client, which is 129, and then I'll go for 190. Brilliant. So that's class C. Taking what we've just known and implanting it onto class B, it's very much the same, except we go into the next octet, depending on what numbers we need, really. So let me just paste in our table. And now we're playing with not the last octet, not the fourth, but the third. So we're working both those last two octets. So if I go for the classic class B private IP address range, so the whole range is 172.16.0.0 to 172.31.255. That's the entire private IP address space for class B, but it's standard class B subnet mask is that. So if I'm using that, I cannot change this bit, and I can use anything in between there. So that's my network, that's my host. So I'm just gonna use that range really. So I'm gonna use anything between 172.16.0.0 to 172.16.255.255. Cool. So that's what I can play with. That's the class full address. Okay. Just gonna plonk that up there. Nice. So if I have a build, let's say I require 1024 at 1018 hosts. Okay. Just as a scenario, for example, I'll leave this number at the side. That's our target network. I want networks with 1018 hosts. I've got a building that are all going to have exactly the same, for example. With this, we have to know that a class C network will increment in 256 times. So if, for example, if I'm playing with class C, if that goes from 0 to 255, then what happens then is this will change to a 1. So then it will be 1.0, the next starting point. Then that goes to 255, and then that goes to 2. So it increments, but we can only play with this section because of the host bits and network portions. Let's just go back. So, cool. Right, so magical number 1018. I'm saying I'm going to use this, but not, I'm going to use my magical table, but not on the last octet. I'm going to be using it on this octet here, because it's class B subnetting now. So if I start writing down networks, okay, and then I can work out what numbers I'm working within, and how many hosts are going to sit within each network. So if I go 172.16.0.0 is definitely our starting place. I can move this over here. I'm glad I can move things. Network. First, last, broadcast. And what happens is, now I write out the full thing, just because it gets clearer. It makes things a lot easier when you write everything out. If you're using VLSM, or if you're using more than a class C IP address. So I've said here, I'll quickly do an example of a class B subnet mask with these numbers, with 1 to 8, and then we'll see how many hosts we get. Okay, so we'll start with adding 1 to 8, but not in that one, but in this one. So 172.16.128.0. Cool. So then we build up, we say what's our last, so what's our broadcast, we take one away, 172.16.127, see, it's already starting to smooth this over, 127.255 is the broadcast, and then we just add one and take one, 172.16.0.1, 172.16.127.254. So we're actually playing with the last octet when we're adding one and taking one away. Great. So now we're going to work out what this one is and see if this fits our logical number. Okay. So we work out the next one. What's our next network? 16.128 add 128 is, oh, we can't do it, can we? Because actually, if we were to add 128 on there, that would turn into 17. And at the minute, we're playing that is the network portion, so we can't do it. So maximum value here isn't going to be this, it's going to be written here. So 172.16.255.255. So we end up with two networks. 172.16.128.1 and then broadcast take away 172.16.255.254. Do you all see where I'm coming from? Because otherwise then the next network is 172.17.0.0 and we can't play with that because we've already said we've got an IP address range, we can't go out of that and we're subnetting it to be effective. Okay, so I'm going to quickly show you how I work out the IP address scheming and our values. So if I go 256 times by 256, that is 65,536. That's how many IP addresses we get within this Class B IP address space. If I do that by 2, which we've got two networks here, we've got 32,768. So we have that as IPs. So 3, 2, 7, 6, 8. Take away 2 because we've got network and broadcast. So 3, 2, 7, 6, 6 that's our usable IP addresses. So if we require 1028, I've got direction on this. Just to explain a little bit more, we have a secondary bullet point here, the yellow one, and now what we're saying is if I have 1, 2, 3, 4, 5, 6, 7, 8 turned on, that would be then a /24. But if I come back one, make this a 0, I have 256 hosts here, 256 times by 2, because that's the number of networks we have. So 256 times by 2, 256 times by 2, 512 here. So that gives us 512 hosts. But we're looking for one above that. So if I times by 2 again, 1024. So that fits within our 1018. So what I'm going to do is use this value, use this one, to get to our point of having 1018 hosts. So just clean this up a little bit. Yep. Just going to clear out the bottom line and this line as well. So we've got the same starting place. Go pink. So we've got the same starting place, and then what we're going up in is our block size in 4, but we're not going up 4 in that one, we're going up 4 in this one. So
172.16.4.0. Then we add and take one away. So if we go 172.16.0.1 and then take one away, 172.16.3. Let me just move that for clarity. .255, and then 192. Oh no. 72.16.3.254. So we've got our usable host range here. And looking at this, because a standard class B subnet mask is 255.255.0.0, and we're stepping into this section here, and we've stepped into this section 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6 times, and where this is 8 plus 6, 16, 17, 18, 19, 20. So this is a /20 IP address. Okay, these are network, and if we wanted to, we could continue 16.8.0, 172.16.12.0. So what we're doing here is effectively breaking down our network slice into more manageable chunks, and reasons why we do this is for security. So we can do a lot with IP addressing with regards to security, like access lists, or stopping set traffic talking to another, or even if you've got sensitive data, you can store it in one element and stop that accessing the internet, for example, just by blocking IP addressing or allowing. It's quite simple. So that's class B. Taking this one step further in quite a simple build, really, and I'm going to use the two clients and the network build again. So just to build a three network build, but different host requirements. Okay, and we're going to use the same numbers as we wanted before, but we're going to base it round on host requirements. Okay, just a very quick, sort of simple, dirty build, really. So variable length subnet mask is about taking our subnets and now using them really effectively, so we don't actually waste any. So if I have a build of 1018, and if I have, let's say, 95. Cool. So what we want to do is use our table again, paste it in, always bring in the table, nicely fits up there. And we have a IP address. What we're going to do is, because we're going to use large numbers, it needs to have that class B start point. You can't ever go back, but you can always step in, so you can't step back, you can always step forward with subnetting. Maybe we should have said that earlier, but so I'm just going to get this, move it over here, probably shrink it, resize, cool. Ooh. 2 seconds. So just stick that down there, and then this is all based around what we already know and making sure you space things out correctly. Broadcast, last, first, get that right over there. So we just have the same network point. So I'm going to go, our stop point will be two different colour. We go for a nice blue. 172.16.0.0. And we said we wanted 1018, and we know it sits within this portion here. It starts within the 4 portion in the third octet.
So we're playing with requirements of a class B IP address really. So what we want to do is add that into our next network. So 172.16 and our block size is 4 but in the third octet. So go up by 4 and go 0. Okay? That's quite simple. So this network here, we've got the network address 4, which is 0.0. And with VLSM, there's a few set rules. So number one is put the host requirements in order of size. So we want to do 1018, then we go 95, and then we do this one. So that's actually, we require two usable IP addresses. So put them in order and then work out your network addresses from there. So we've got that one done. We've got the network address for it anyway. So, and also within VLSM, because they're going to have variable length subnet mask, I'm just going to shift that over and put CIDR. Oh, CIDR. Our CIDR address. So that we know what our subnet mask is, and we can apply it appropriately. And also when it comes to really configuring your IP addresses within a big build, subnet masks are one of the most important things, because if you don't get that right, either you'll stop the communication between your network or you'll allow too much. So we start at 4.0 and we need 95. So within that, where are we going to play? We're going to play within this section or this section based on our number. So our block size, actually our 95 that we require, fits quite nicely here. We can't go smaller, which will be 64, but we can always go over. We can always, we need to make sure we hit the number but not reduce it. So we're going to use 128. So we're going to use that 128 number and work out our next network. Okay. So I'm just going to take a few bits off. So go back to it. 172.16.4, and then we said 128. So we add 128 here. And then we need so we've got our 95, which our block size is 128, and we just need to work out, we've got our start point for our 2 network, got our start point, but we just need to work out our block size. And we've already said my favourite subnet mask and starting point is our point-to-point, which gives us 4 IP addresses, 2 usable, which perfectly fits this point-to-point connection, point-to-point connection here. So if I go 172.16.4, and we're starting at 128 and we add 4 to that. So 1, 3, 8, 9, 10, 11, 12. 132. I even had to check that myself. So that's our next network, and actually that's our new starting point if we needed anything extra. There is a little bit of a caveat which I'll touch on there. So what we do is we add in the rest of our numbers now. So I'll just do it in a bit of a different colour. We add 1, take 1, and work out things from there. So 172.16.0.0, 172.16.0.1, broadcast 172.16.3.255. Nope. Yes. 172.16.3.254. And we said this here, we're using the 4 block size of 4, subnet of 252. So we can say subnet mask is 255.255. Zoom in. .255.252.0, which if we count the number of ones for CIDR, we've got 8, 16, 17, 18, 19, 20, 21, 22. Oh yeah, well actually, sorry, that was a 22. My previous, so 16, 17, 18, 19, 21, 16, 17, 18, 19, 20, 21, 22. That was a 22. So the previous, sorry, I stand corrected. The previous Class B CIDR was a /22, not a 20. I do apologise about that actually. I can make a correction in the video at a later date. So what we're at is a /22. And then we've got our next line. Doing a nice Holton green. We've got our 4 starting point. You have 172.16.4.1. Look at the next network, 127. So 172.16.4.127. 172.16.4.126. And now this one is within the Class C, or the last octet that we're playing with, so that's now past 24, so 24's here, 24, 25, so that's a /25, and then we've got our last network, which our next network working number is 132, so our broadcast is going to be 131, so let's just choose a different colour, go for a nice yellow. Oh, I already used yellow. It's like I'm randomly choosing red. Cool. 172.16.4.129. Oh no, stand. Yeah, 129. See, it's quite easy to get lost when you've done so many numbers. We'll do broadcast 172.16.4.131. What is just counting, isn't it? 172.16.4.130. So now we can apply this IP addressing to oh, that's a /30 or 252 Subnet Mask within that Class C. So we can now apply this to the previous diagram. So let me just bring this back quickly into the middle. What we'll do is just write it in on red. So first network .1, and we use the last usable, so that's 3.254. I should be writing a full IP address on this diagram with interfaces, and that's something that I'll show you a quick video of when planning out a network diagram. Is actually time spent planning is never wasted, especially if you get the procedures right initially and you get them bigger, the fundamentals never change. So then we've got 95, so our 95 network was this one, so 4.0, 4.0 starting point, so 4.1, then 4.126 was our last usable, and then this point to point is 4.129 and 4.130. So actually we've used our build effectively. We've got lots spares, so we've actually got 4.132 all the way through to 255.255 with the 172.16 network. Cool. I know it looks like a headache, but that's our basic subnetting and variable length subnet masks on the fly anyway. So next video I'm going to be doing, I'm going to take a break now and then move into the next one. We'll be configuring those IP addresses and implementing the build that we've got on our Cisco packet tracer. So I'll show you how to configure IP addresses and check them within Windows, within Linux, and then on Cisco, both on a switch and a router. So see you back there.